let's talk about how you can solve this problem. How many people set up the first way, where you just rewrote this as a fraction? How many did the second way, where you multiplied top and bottom? Okay. The rest of you just waiting to see what I do? Okay. So let's talk through the first way. If you treat this in the first way, now either way is fine here because the denominator, the factors in your denominator number 2. So anything 1 or 2 distinct factors or different bases for those factors will be fine for the second method. But probably the first method will probably be a little bit more efficient in this form simply because there is no fraction in the denominator. I mean, really, you're looking at this whole thing. So by doing the first step or the first method, your bottom fraction is already done. You don't even need to do anything except for invert it. Okay, but let's take this top fraction and combine it into one single form. So we need a LCD of x and of a. Okay. When we take our first fraction's numerator multiplied by the LCD factor missing from its denominator, which base is missing, or which factor is missing from this denominator? So 1 times a is just a. And then minus the next fraction's numerator times what LCD factor is missing from its denominator? X. And so here's your solution right here. It's as simplified as it gets. The denominator is already simplified. And so all you need to do now is turn this into a multiplication problem. We invert and multiply. Here's the one source for the majority of mistakes on this type of problem is treating each of these terms as an individual part, and flipping it, like saying 1 over x minus 1 over a. That's what a lot of students will make that mistake. And x minus a itself is a factor. You have to treat the entire thing. So again, anytime you don't have a fraction, go ahead and write over 1. It often helps. When we invert and multiply, we wind up getting our denominator or our factors set up correctly. Okay, now there's one more thing to think about here, and that is this first numerator is not it's not consistent with the rules that we've established, which is all factors are written with the x first and with a positive leading coefficient. So what can I factor out of this? Take out a negative, and I'm left with a x minus a. Again, remember, change the signs of each of these. Okay, and so now when I look at this, the x minus a's can cancel, and I multiply across the top a negative 1, multiply across the bottom. I'm going to put a first simply because usually the first letters, early letters of the alphabet generally represent some kind of constant, some numbers. So it's not always considered like the variable of it, but it's a placeholder for a constant. So ax, even if you put xa, that would be okay though. All right, and am I done? Okay, I canceled out a factor from the denominator, so I do need to account for that domain restriction. What do I know x cannot equal? It can't equal a. And when we look at, again, it's often a good idea to go back and double check everything. Can x be a 0?
No.
Is that shown in the simplified form? Yes. Can a be 0? No. Is that shown in this form? Yeah. Corbin.